Alright, what's up everybody? I always like to do a lesson where I play Minecraft towards the end of the year in year 11, but unfortunately this year we're a little bit short on time, and so I'm not going to be able to do that. So what I figured I'd do is I'd make a YouTube video to basically show you the kind of logic gates you can build in Minecraft, to just give you a bit more of an understanding of what these things are used for. So we're going to go in. I've made a new map. It's been a while since I've played this game, so hopefully I'll be able to remember most of it, but we'll start with the very basics. So this torch is kind of like a battery, kind of like a power source, and what we can do is we can run some wire away from it, and you can see that the wire will light up as the torch is powering it. At the end of that we can put a light, and the light will turn on, especially if I show you this at night time. I think it's that. See, the sun's just going down and our lights will light the place up. Now I can replace the torch and the lights will go off. I can replace the torch with a lever, okay, and when I flick the lever the lights come on, and I turn it off, the lights go off. So we've got a very basic circuit there. We have to imagine that the current flows in through this wire and then flows back out through this wire. Most of the time you're not used to seeing wires that go you know, round in a whole circuit. Like, you think about it, when you've got your lights or you plug something in, you don't see then a wire coming back out to the power supply. You normally see just one wire, and that's because that wire is actually called a cable. So the wire going into the lights is in it, and the wire coming out of the lights is in it to make a complete circuit. So let's get rid of this wiring here and take a look at what else we can do. So that's a very basic electronic circuit. What we can do is we can replace the switch, well, not just replace but add to it, by building this. We put a torch on there like that and then run a circuit away from this block and stick a lever there. Now what happens is, and in fact actually this works better with a button, so let me put a button there. There we go. So what's going to happen when I press this button, the light goes off. So that's a little bit weird, isn't it? Because what you might normally expect, if we didn't have this torch here and we you know, we short-circuited this like that, when you press the button the light comes on, when you press the button the light comes on, and then it goes off again. But when we make this setup here, like, oh, not that there, stick that there, then you can see the torch is powering the lights, and as soon as we put power into the torch turns off. Just watch that again. As I put power into the torch turns off. Now I need a sign to write down what that's called, so I'll stick that there. We'll put a sign on that. This is called a NOT gate. And what it basically says is the input at the moment is 0, the output is 1. And when we change it and make the input 1, the output is 0. Okay, if I flick that to a lever, you can see that. Input is 0, output is 1. Input is 1, output is 0. So that's your NOT gate. So that's the first of our gates. Now the next one, I'm going to stick the lights back on just so it's a little bit brighter to work in. The next thing we're going to look at is an AND gate. In fact actually we'll do an OR gate first. So an OR gate works a little bit like this. We put our lights over here and we put our circuitry. I think we can just run it. In fact, let's just have one light. In fact, let me rebuild this completely. We're going to stick these apart a little bit further apart so that there is one line in the middle. Okay, so both of those come in and then the light is in the middle. And here I'm going to put a, apologies about that, that's my emails coming through. If I flick this switch, the light turns on. If I flick this one, the light turns on. Let's replace them with levers to look at that in a bit more detail. One lever there, one lever there. If I turn this one on, the light comes on. If I turn this one on, the light comes on. And if I turn them both on, the light stays on. So this is a OR gate. OR gate. Let me write that out. It's an OR gate. And what it basically means, if this one or this one is turned on, then this is on. So if the input of this is 0, or the input of this, and the input of this is 0, it's off. But if this input is on, or this input is on, then the output is on. And if they're both on, the output is still on. So we've got so far our NOT gate, that basically reverses the signal. We've got our OR gate, that tests whether just one of these switches is on and turns it on. Next we have an AND gate. So have a little think as I'm building this. This one gets a little bit more complicated. How does an AND gate work, or what does it do? A bit of that goes there, and this comes out here to our light. There's a chicken over there. So on this one we'll have two switches like this. Now, did you guess this correctly? For an AND gate, if they're both off, the light is off. If one is off, the light is off. But if both are on, then the light turns on. So this is our AND gate. AND gate. And what that basically says is if this one and this one are both turned on, the light will turn on. And so that's our AND gate. Now there's only another couple that you need to know, and that is combining a NOT and combining an OR. So let's make that. These two come together, then they go to, do you remember before we made the OR gate, the NOT gate, it looked like this. Well, we're going to do basically the same thing. So we're going to stick that there, have a torch on the back of it, have some redstone, which is the wire, and the light. So this is now a NOR gate. So I'm going to get rid of the sign and I'm going to replace it with a NOR gate. You can see that it's like combining a NOT and an OR. Turn these off, let's have a look what happens. So if they're both off, then the light is on. But if one of them is turned on, the light goes off. And if both of them are turned on, the light stays off. The only way the light is on is if both of the inputs are off. Now the AND gate. Can you guess what this is going to be called when combined with a NOT gate? Well, let's remove our block first of all. Put a NOT gate on it. And there we go. Let's make that twice as high. Now what happens? Well, in this case, if both switches are off, then the light is on. If one switch is on and one is off, the light is on. Just toggle that the other way. Or finally, if both switches are off, the light goes off. Oh no, sorry, both switches are on, the light goes off. But if both switches are off, or one of them is off, the lights are on. So it gets kind of complicated, but there's some easy ways to remember it. This is a NAND gate. So what I'm going to add into this video is a little bit of footage that shows you the tables that go along with this to try and pick up on the ways we work this out. These are called truth tables, and once you get the basic hang of them, they're pretty easy. But all you've got to know for the exam is the NOT gate, the AND gate, oh that's the AND gate, the OR gate, then the NOR gate and the NAND gate. Okay, hope you enjoyed that and it made some sense. Don't worry about this redstone stuff, it's a bit crazy. The idea that you get is the most important thing. You might wonder as well, what's the use of these gates? Well, if I just flip this back to being an AND gate, one of the things I always like to think about is this being used on a nuclear submarine. So if I can replace both of these with buttons and replace some of the lamp with some explosives, TNT, let's put that down here. If this TNT gets powered, it makes a big explosion. And as you know, nobody wants nuclear warfare, and so that's why on a nuclear submarine or a similar device that can launch a nuclear attack, there isn't just one guy who controls this being turned on. So if I flick this switch, nothing happens to the TNT. And if I flick this switch, nothing happens. And if I try and do them both really quickly, well, I might just be able to do it, but you could imagine that if these were further away, I click this one, I've got to run over to this one. By the time I've got there and clicked it, it's just not going to happen. So what we do is we have two guys, both with a key, so they can turn the keys at the same time and explode the TNT. So that's a use for an AND gate. Let's see if we can do it. If I was very quick and I was able to run with the speed of 2 men, boom and boom, there we go. They both turned on, and the TNT explodes. That makes a big hole. And the sun's rising. That's pretty beautiful. Anyway, hopefully you've enjoyed that. You have some kind of an idea of what a logic gate is for and how we can use them. Okay, so here are the actual truth tables. So we'll look at them one by one. First of all, here is the NOT gate. Now these symbols represent the type of logic gate you have, and you do need to learn these. So you can see if the input is 0, the output is 1. If the input is 1, the output is 0. Pretty simple. Next we look at the OR gate. There's the symbol for it, and it basically says if both of these are 0, the output is 0. But if one of them is 1, the output is 1. And you can see if one of them is 1, the output is 1, or if both of them are 1, the output is 1. So if one of these is turned on, or is true, or is a value of 1, then the output is 1. Check out the NOR gate then. Now I don't think you need to know the symbol for that. I've never seen a question asking that. But if you look at it, it's quite interesting. And actually I've just noticed there's a mistake on that. Because the way you figure these out is they're always the reverse of the one above it. So I'm actually going to erase this, because that one is wrong. Right there, that should also be a 0 in fact. Okay? And the reason for that is all you do is you think about the OR gate and you reverse every signal. So 0, 0, 0, 0, 0, 1. 0, 1 gives 1, or 0, 1 gives 0 then. 1, 0 gives, 1, 0 gives 1, then 1, 0 gives 0. You can see how that works. Finally then, we need to know the AND gate. So here is the AND gate. Again, you need to know the symbol for that. You can see it's more curly than the OR gate, which is pointed. If it's 0, 0, it's 0. So if both of them are off, then it's off. If one of them is off, it's still off. They both need to be on for it to be turned on. And you can see that this one is correct, the NAND gate. This one is reversed. You can see the table is reversed, so that it's 1, 1, 1, 0 instead of 0, 0, 0 is 1. So the ones you really need to learn are the NOT gate, the OR gate, and the AND gate. Oh, hello Gak. And basically if you know these three, then you can combine them together to make the NOR gate and the NAND gate. And the way you do that is you draw the truth table for the OR gate and you just reverse the output. Yes, I won't buy a new guitar today. Just reverse the output and then you'll get your correct answer. Often in these kind of logic gate questions, you can just draw the truth table and that will get you full marks. But I always recommend you explain what's going on at the same time. Hopefully that's helpful. Mr. Perry is now out of here.